Morning, everyone. Welcome to our week 3 of MATH13218 Advanced Application of Mathematics. Today, we'll continue our discussion of first order linear ordinary differential equation, that is ODE. Okay, so what do we mean by linear differential equation? So I was getting some queries about the wording and everything, so I'll go a bit deeper and explain each word of it. So first of all, differential equation, right? So it's an equation. I mean, it's already covered, but I'm just repeating, so you don't have to go back and refer to the slides. Differential equation is an equation that contains the variable as differentiation. So it could be dy by dt, dy by dx, dv by dt, all that kind of thing. So there is one dependent variable, that is mostly y, which is a function of x. So x is independent variable. Now we talk about ordinary differential equation, the word. So we know what is differential equation. Differential equation. Now we talk about word ordinary, right? So ordinary and partial are two types of differential equation. Ordinary, everything is dy by dx, nothing partial. Partial differential equation, say you got an equation x squared plus 2xy plus y squared. You'll have a different approach for ordinary and partial. Ordinary is represented by d by dx, assuming y is a function of x, while the partial is del by del x, where you are only differentiating everything in x, right? All the y term are treated as constant. Okay, so that's a difference of ordinary and partial differential equation. Now we talk about linear ordinary differential equation. We refer is at ODE, linear ODE. When we say linear, the power is 1, like linear equation on a line, the power is 1. Whose power is 1? Dy by dx. If that's your variable, it's power. Even though it's a differential equation, we consider dy by dx variable just to understand that. So you'll be talking about dy by dx, not dy by dx times, or its square or something like that. Okay, so then we treat it as a linear. Now, first order. So there are two concepts. One is the order, other is degree. The more reference book you refer, you'll come across many other terminology. If you ever get confused with different terminology, please get in touch. I'll help you where I can. Now, when we say about first order, the order is dy by dx is 1. d2y by dx2, order is 2. d3y by dx3, like this one, order is 2. If I talk about 3 here, then the order is 3. Yeah. So we are talking about only equation containing dy by dx, that's first order, right? Hope that makes better sense now. Again, if you ever get confused, please get in touch. Yeah. Now, standard expression of first order linear ODE. So they will contain dy by dx plus px, some function of x, times by y is equal to qx. If the right-hand side, this qx is 0, we call it homogeneous first order differential equation, linear differential equation. An example of this is dy by dx plus 1 on xy is equal to 2 e power x squared. So here p, as you can compare, is 1 on x and q is 2 e raised to x squared. When we talk about the homogeneous, again, it's been covered in earlier weeks, but when we say homogeneous, the right-hand side is equal to 0. One of the easy solution, which we have seen with the help of separation of variable, is your y is c, which is some constant, e power negative px dx integration. Okay, now last week I was getting some queries about, some steps, which was difficult for many of you. So I conducted some special session that was on a Friday, 12 p.m. So last Friday, 12 p.m. If in future, like I prefer everyone to attend the class and ask the query, because I don't want to set a norm saying that, oh, we won't attend the lecture, maybe not watch the recording, and we'll ask any queries we like. I mean, that's unfair, as you will understand. You are kind of in the same profession, so you can easily connect it. But what I'm saying is, if you still struggle, I'm not like, oh, you didn't attend the class. I have no proof you watched the recording or something, and that's why I won't help you. It's not what I'm saying. I helped someone last week. I'm happy to help that again. Maybe half an hour, 1 hour session occasionally, once every fortnight. Keep up your doubt, and bring it to me, and then we'll discuss, right? Rather than me writing long email, it's like reading a letter. I mean, the more you talk, the more we discuss. It will make sense. Yeah. So please, email me your query. The only point I will insist is revisiting your integration part from last year. Without that, you will always come up with a lot of queries. All the formula, the integration by parts, the UV rule, the LIAT part. If you haven't seen that, again, get in touch. I'll explain that. But all that kind of thing, that will help you understand all this concept a lot in detail. Differential equation is just a technique of integration, bit in depth, but they are like 80% of the part. You are just talking about integration. So if that portion is weak, you will never, ever be able to excel in these topics. Yeah. Right. Let's keep going. Now I will explain why this differential equation has this as the solution. Okay. Okay. Sorry, what I meant was, solution of the homogeneous, not the other one, right? Okay. Okay. So what we got here is dy by dx plus dxy is equal to 0. We have the same approach of variable separable. Okay. So what we do, we try to separate the variable dy by dx is equal to minus p of x times y. You don't have to keep on writing p of x. You can simply write p. But back of mind, you should understand or remember that p is a function of x. And then only you can integrate with respect to x, right? We keep the y and x term on either side. So dy over y is equal to minus p of x dx. And then we do the integration. Okay. Again, in that extra support session last week, we had that discussion about what should you choose. Should you choose C, LNC, or something else? How do you know? It's just by bit of practice. Even if you practice a couple of questions, you'll realize that if your Y has ln after you integrate, it's preferred that you choose the LNC. It will reduce 1 or 2 steps and bit of complexity, right? So here I'm going to choose LNC. So lny, again, where do you keep integration constant? Either side, left or right, doesn't matter, because you have a lot of choice of choosing integration constant, and nowhere it's returned it has to be C. If my name starts from D, I wanted to go for D, I can go for D, just as long as I'm not confusing D and dx and constant D. And that's why you kept it C. You could go for K. You could go for T. As long as you are specifying it, alpha, beta, gamma, whatever you like. Okay. We choose C because most of the literature follows integration constant as C. But whenever required, we could have gone for C1, C2, C3, C dash, C double dash. But again, dash will conflict with the differentiation. So that is the reason why we stick to a particular constant C or C1, C2. The more iteration you'll have, the better. The more practice you do, the better you will be with choosing a particular integration constant. Another query was, since I'm integrating everything in one step, I don't get like left-hand side C1, right-hand side C2, kind of thing. And what you might have done in past is, as you integrate once, you leave one constant. I could have done that. I would integrate this part, call it L and Y. I would integrate this part with whatever, I don't know yet, but whatever that is. And then I'll have C2, right? And then C1 minus C2 or C2 minus C1, I'll call it a C. Or wait until the end, integrate everything in one step. Yeah, right. So since we are integrating here, minus, I don't know P, I'll have to leave it as it is, but I'll have a constant which I will call LNC. Okay, right. If it is y, ln y, it will become e raised to minus px dx plus ln c. Property of exponential, you can separate the addition. So your y, I'll write the c part first, times by e raised to ln c is the definition of exponential. C e raised to minus px dx. That is the solution of homogeneous linear differential equation of first order. This bit. Yeah, this bit. Right, so what we do, we memorize it. Of course, your formula sheet can cover this point, but I would strictly insist that you have to memorize it. You cannot simply rely on a formula sheet all the time. What if you don't have that? And formula sheet, it will stop your brain from functioning, answering most of the questions. So it's like a lifeline, but don't 100% rely on it all the time. Okay, right. Having a look at that, this is a solution where c is a constant. Let's dwell into some of the example. Right. So dy by dx plus 1 on x, y is equal to 0. Okay. If you look at that way, see, what we have done in these steps here is using variable separable and giving you a straight answer, right? But you could have gone for that, okay, I don't want to follow this solution. I wanted to go on my own, trying on my own without looking at any bit. You can always, by all means, do that. Okay, so I'll give you two approach here. One is using the formula. Okay, okay, I got it here. Okay, what I will do, I'll use this slide and do it normally. Here I will do regular approach, the solution approach, CE power negative integration px dx. That's what I'll do here. And this pair slide, I will integrate with variable separable. And then you can choose. I mean, it's good to practice the new method because that will help you with non-homogeneous as well. But let's try that. Okay. So what we got, dy by dx plus 1 on x, y is equal to 0. You might even feel like this is easier than the other bit, but it's practicing. Sometimes the other one is a lot better. Okay. So dy over y is equal to minus 1 on x dx or dx over x integrating. I keep the constant outside. ln y is equal to minus ln x plus ln c. Log property ln c over x, which will lead to y is equal to c over x, and that's the solution. Not quicker, easier, because we have been doing that. But again, like I said, choice is yours. No one will compel you using only the CE power negative integration px dx, but that's a helpful technique. And many times you'll get stuck, and then this is the way. Yeah. Okay. Right. dy by dx plus 1 on x is equal to y. We will approach the p method, which we have just learned. So comparing this with dy by dx plus px times y is 0. By comparing, obviously, I get my px is equal to 1 on x. Okay. My solution is what? Y is equal to c e power negative px dx. Therefore, y is equal to c e raised to minus 1 on x dx. This is, can I say ln x? Now c is already there. So you can keep going c1, c2, blah, 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 and then come up with a c, but this is a solution. So all the extra c1, c2 requirement is being taken care of. Now, can I say it e power 1 on ln x? Sorry, not 1 on ln x. Ln 1 on x, or x power minus 1. Yeah, if that's still not clear, you can write ln x power minus 1. which will then lead to y is equal to c x power minus 1, because ln reciprocal function, inverse function, sorry, and they will cancel each other's effect. So y is equal to cx minus 1 or c on x. As it turns out that in this example, maybe doing it the variable separable way is easier. But like I said, by all means, you can adopt one or the other method. Right. Let's look at the next example. Right, so since we cracked the first example, now it's time for us to move to the next example. dy by dx minus 10x times y is equal to 0.
Hang on, mate. Hang on. Sorry.
No, you're right.
I will turn my audio off unless I have a question to ask.
Yeah, sure.
Thank you.
Okay, so again, we will compare this with the standard form dy by dx plus pxy is equal to 0. That will straight on give you px is negative 10x. Right? Now, it's essential you figure out it properly. The reason being, it's a part of your integration. So if you get that one wrong, you will kind of end up in big trouble. Right? Okay. Now, you know that you will have to integrate integration px dx. So either you can start writing and then realize that, oh, I need to integrate it. How would I do it? Or be a smart fellow and do the integration part first. Because integration of 10x, like I know it, is log sin x. But if you don't know it, I mean, as a log is ln, sorry. If you don't know that, then it's better you do that step first. So let's talk about that integration first before you actually go for solving of differential equation. Right. So integration of px dx, that is integration of 10x dx. I will not worry. Yeah, let's leave it like that. Okay. What do you got? 10 is sine over cos. Now, those who are watching the recording, I would insist you pause the recording here. Think about a solution of this. Think about a solution of this, right? How would you integrate this part? Okay. Now, how would I do it? I would assume my cos x as t. What is differentiation of cos? That is negative sign. So negative sine x dx is dt. Okay, so what that means that this will turn as dt over t, isn't it? This will turn as dt over t. So dt over t, what do we do with that? Is ln t. Right, so this here would be, sorry, not this, ln of cos x, that is integration dx dx, ln cos x. Right, so when I talk about my y as a solution, we know what is y. C e raised to minus dx dx. C e raised to, since I know the integration part from earlier, integration px dx is ln cos x. Okay. Can I say it ln cos x power minus 1? E and ln will cancel. That will be simply c times cos x power minus 1. C over cos x, or you can say c secant x. Either of them is a good approach. Yeah. So again, you memorize the formula that the solution is y is equal to ce power negative px dx, but the majority of the question lies around the central part of integration. If you don't get that right, you will never get the question right. Okay, right. Cool, let's keep going. Now we talk about non-homogeneous, so where the right-hand side is not zero, right? What we have seen so far is for the homogeneous differential equation. Now we show the differential equation which are not homogeneous, right? Now, those who have the book and maybe the latest version of book, you can always refer that and you will come up with this as the solution. Like it's too big me to explain that, but you can always refer to various book has various different words. I was referring to one book yesterday night, which talk about integrating factor, which is called as IF, and you keep it that, like just like that, Professor William has a different approach. Of course, there is no right or wrong. Even I can't say my teaching is good or the person's teaching is bad or this slide is good or that slide is bad. It's a different approach, right? No book or no author or lecturer will ever be able to justify every student's needs. If it's face-to-face, one-to-one, then of course we cater to those individual queries. But when you are reading from a material, it can't have 10 different approach. Yeah, okay. Right, so if a given equation dy by dx plus pxy is equal to qx, then the integrating factor, which we call mu x, is e power negative px dx, which is similar to what you have seen, except the factor c. But the general solution will be mu x bracket c plus integration of qx over mu x dx, and then you replace or multiply with the mu x value. You just substitute that bit here, right? And then that's your part one. And when you multiply, that's your part two, right? Since mu x is in denominator, the negative sign will go. So qx times integration of this bit here is tricky. I request again, please go over to your last term integration bit. If you need any help, get in touch. Get in touch, right? Right, let's look at some example. Okay. dy by dx plus 1 on xy is equal to 2e power x squared. Your qx is a healthy term, right? Now, let's take it step by step, right? Let's see how many slides I have. I think that's enough. Yeah. Okay. Comparing this with our standard equation dy by dx plus pxy is equal to qx. That will give me my p of x is 1 over x, and my q of x is 2e power x squared. Okay. Now, I would urge most of you take a screenshot here because you will need to refer that, or from your phone selfie or capture this part and keep it handy, because we're going to talk about like solution one and solution, the first part and the second part, right? So first we start with this mu x part. Okay. Okay, it's important to find the mu x. So integration of, right. So let's start with that. So here, first bit, mu x, which is integration of minus px dx. What is px is 1 on x. Okay, so that is integration of 1 on x dx. Integration of 1 on x is ln x. That would lead to e raised to ln 1 on x or x power minus 1. And therefore, your mu x is 1 on x. That was a bit easy part, right? Now, again, if you have to write this, I mean, this is a better way of writing, isn't it? Yeah, this is a lot better way of writing. This is just multiplying as replacing the value, but looks very horrible. So I would say, okay, this is decent fella to take care of, right? So mu x bracket c plus integration q over mu integration dx, right? So we write that bit here. What is our solution? The solution y is mu x c plus integration of qx over mu x dx. Okay, now before you start writing and writing and writing, what I would do is take care of this part here. If that's been taken care of, then it's just multiplication and simplification. So I wouldn't keep on caring writing mu x integration bracket c plus integration blah 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 blah. Take that out and deal it separately. So your whole equation doesn't look horrible. Because in order to integrate this, again, you'll have to assume some t or v or something like that. We'll see when it comes, right? But tip here is to just take care of that part, right? So I would write where integration 2x over mu x dx. Let's deal that separately. You can call this equation whatever. Let's call this 1. Let's call this 2, right? And we will replace that value in equation 2 once we have a integration being solved, right? What is qx?
Can I ask a quick question?
Please.
For mu x, how did you go from to the power of the negative log of x? Do the e and the natural log cancel out? How come x turned into 1 over x?
Okay, I just did that in earlier example, but I'll explain it. What is the property of like? Forget about e for now. What is the property of ln? Power goes in multiple, and same way anything multiple goes in a power. Yeah.
Yeah. Yeah.
Okay. So can I write x power negative 1 here?
Oh yes. Yeah.
Right. Now, what is the relation between exponential and log?
Sorry.
What is the relation between exponential and log? They are kind of inverse function, right?
Yeah. Okay. Yeah.
So what we mean by inverse function, f inverse of fx, what does that give you? Simply x, isn't it?
Yeah.
Yeah. So e and log will cancel out, leaving you simply x power minus 1, isn't it?
Yeah. Okay. Yeah. Yeah.
Right? And x power minus 1 is the same in 1 on x.
Yeah. Yeah.
Make sense?
I knew how you got rid of the e and the log, but I couldn't figure out how you went from x to 1 over x. But I see now.
Yeah. No, that's fine. Yes. We are here for a reason, right? And it's keep asking question. I'm very glad that you could make it. Any doubt, and even those who are watching, any doubt, anytime, please raise your voice. Ask me. If you don't ask me, I feel, it's fine. Yeah.
Yeah. Thank you.
Okay. Right. Let's keep going. I'll use the red pen, the standard color. I mean, it's a stupid thing to ask, but if someone gets annoyed with the red color, please ask me to change it. It's just default, so I keep going. But if you prefer green or blue as a standard color, let me know. Yes. Okay. So Q. What is our Q? I believe e raised to x square, 2e raised to x square over mu is 1 on x. Right. I just rearrange 1 on x, denominator 1 on x, that will become 2x e raised to x squared dx. Normally, I leave 2 outside, but there is a reason I'm keeping it here. Now, whenever you got multiplication of two function, first of all, you have to ask yourself what can be done about it. Is it just integration uv dx, integration by parts, or is a function along with its derivative or something else, right? So again, refreshing our memory, and I keep saying that, please, please, please revisit previous year content of integration. I'm sure you'd have seen a formula where you got fx power n times by f dash x, then that would be fx power n plus 1 divided by n plus 1 plus f integration constant c. Okay, we've got a function, some power, 1 or 2 doesn't matter, along with its derivative, then you increase the power of that function, right? I'm going to use the same approach here. So what I will do is I will let this goes here, my x squared as t, and therefore 2x dx will become dt. So this integration will turn as, I'll rewrite it before turning it. So what I will do, e power x squared 2x dx, which will turn as e raised to t dt, and its integration is e raised to t. Right? Plus c you can write, but if you just observe on the slide here, we got plus c here, so that c or c dash c1, c2, like I explained, that everything will be combined and just one c is fine. Yeah. Okay. So we got that bit sorted. E raised to t is a borrowed variable. I'll have to replace it back, and that will be e raised to x squared. Right? I write a bit nicely. So what we got here, integration of qx over mu x dx is e raised to x squared. Like I said, don't worry about c. Now from equation 2, what we have, the solution y was mu x bracket c plus integration of qx over mu x dx. Mu x, which is 1 on x, c plus e raised to x squared. See, if you had not split it out and taken care of it separately, what would happen? You're carrying that step every time, and that becomes a bit horrible to take care of, trust me. Yeah. So whenever you find that's a bit complicated, just separate it out and delete separately, right? And that's it. That's your answer. Only the integration part was kind of tricky. Once you take care of that, I think that's it. Any question?
Not so far. Thank you. That was good.
Okay, cool. So let's keep going then. Okay, again, those who are watching the recording, I would say pause here for a minute, try to solve it, and see how you go. Okay, I'll pause the recording. Right, I hope that would have bought you some time of trying things. Okay, now those of you thought that this is your P and this is your Q, you're very partly like a minute percentage correct, because you disregarded the fact that there is this cos x waiting for you along with dy by dx. Now, the first step you should do is make dy by dx alone. Without that, your whole P and Q will be wrong. A P and Q is wrong. You are integrating something which is wrong, and everything is gone by. Okay, right. So first step is to divide by cos x. So my equation will be dy by dx sin x over cos x y is equal to sine 2x. Those who remember it, sine 2x is 2 sine x cos x. And those who don't, please revisit your formula sheet, right? Okay, so this will be dy by dx. You can leave it as it is or Some smart fellow will tell that it is 10x. It's fine. You're going to integrate that. That's what you need. If you prefer to leave it as it is, that's fine as well. That will be gone, and 2 sine x. After this step only, you will be able to fetch correct P and Q. So this is a P and this is Q. So my Px is sine x over cos x, and Qx is 2 sine x. Yeah. Okay. Once I get that, I have to find mu. That's my next step. Okay. So mu x. Again, pause the recording. Think for a moment. What is your mu x? The more you test your brain, the better you will be, right? What is mu x? E raised to integration minus px dx. Okay. What is p? Sine over cos. Negative sine x dx over cos x. Now, if you do a few special practice, few example practice, by now you should have realized you don't have to go for that cos x is t and therefore negative sine x dx is dt, right? Okay, so I'll write few steps here, which you can resemble from some of the books, right? First, can I write this as e power differentiation of cos x over cos x dx? Some book might even say that after assuming fx and everything, this is f dash x. Let's not go for x, let's go for t, right? Or those who really wanted to go step by step, let's split it out. Let cos x as t, and therefore negative sine x dx is dt, and this integration will turn up as dt over t. You don't have to do any of it if you are confident enough. Showing step does not mean showing every baby step. There is a difference. If you wanted to, fine. Just to ensure that what you are doing is step by step correct. You don't mess up. You don't make any silly mistake or big mistake. That's fine. But when we say step by step, it doesn't mean that every part of the step has to be captured. If you're smart enough, if you have figured out in your brain somehow that this is what we are talking about, the next step could be simply this is e power, of course, ln t. So sorry, integration is gone. ln cos x. That's it. And if you want, this is what is e raised to ln t, and t is your cos. This is all side bit, which you can skip. Approach 1, 2, 3. Some book will say like this. Someone would assume fn, f of x and f of t and kind of this thing, or simply variable t. Okay. Again, e and ln will cancel out. They are reciprocal. Sorry, I keep saying reciprocal. They are inverse function. And that will leave you your mu as cos x. So mu of x is cos x. The more equation you call out, the better for you. I haven't said anything. So mu x is my equation number 1. Right, I'll write the solution. Y will be, who will remember the solution? Mu of x, c integration q x, mu x dx. Let's call it equation 2. Okay. Again, my preference is following what we did earlier, splitting out this q over mu section and dealing it separately, right? So I would say where integration of qx over mu x dx What was our Q? Q was 2 sine x. Mu we just got as cos x dx. Okay. I don't need 2 here, so I'll keep it as it is. Right. Now, if you want, borrow a minus and keep it here. You'll ask, why did I do that? Because cos differentiation is minus sign, like I just did here. You know, when you say cos and sine and cos, you should now be able to connect. We did like ln cos, ln of denominator, right? And that's why I needed a minus, because cos differentiation is minus sign. So straight on, I could jump to minus 2 ln of cos x. Okay. Why do I have absolute value? Because log does not adopt the negative number. So absolute will make sure that it's always positive. I mean, it does, but it's turned out to be a complex number, not a real number. If you ask your calculator or Google what is log of -4, for example, it will throw up like 2.2 something, 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 plus I something, something. Yeah. So it exists, but not that we know, not that we have seen. Okay. So we keep it like this. Right. So that's our difficult bit taken care of. And if you want, you can take care of the negative and not, but leave it as it is for now, because we are yet to simplify that. Okay. Oops, I ran out of space. Okay, I'll use this part. So from 2, your y, which is mu x is cos x. See? And this is minus 2 ln cos x. That's it. Yeah. Okay. We just simplify. What can we simplify? You can multiply with cos inside, but that's not going to simplify anything. So I think that's it. Y is equal to cos x bracket c minus 2 ln cos x. That's your answer. That is your answer. That's it. Okay. There you are seeing the entire question, right? First of all, finding P and Q, easy bit. Provided we don't forget the multiple, divide by multiple, right? Once you figure out P and Q, you are doing two integration. First of all, for mu, integration of minus e raised to minus px dx, whole integration. Be a pro now in that one. If you're not, you are losing a lot of time and accuracy as well. Once you figure out that that's how it's done, then y is mu x. Again, one more integration. Figure out that, put it back. That's it. It's just some steps of simplification. Okay. Okay, let's keep going. Next question. Someone was asking me the other day about that they struggle with the worded problem. I got an email, I think. The only thing is you have to be really good at, first of all, the basic stuff, and then picking a worded question one by one. I can shoot some more example of worded problem or some reference book which has greater word problem. Okay, I'll shoot it soon. Okay. Right. A curve goes through a point 1, 1. Its slope of the tangent. Now, when you read this sentence, slope of the tangent, the instant thing in your mind should be, I'm talking about dy by dx. If that's not coming to you, even after a recent practice, then you will always struggle, right? Slope of the tangent is dy by dx, right? So this is my dy by dx. So the question has indirectly given you dy by dx. Okay. Now, 1, 1 is like when x is 1, y is 1. That is to find the particular solution towards the end to get rid of the constant and all that unknown. Okay. So find the function of this curve. That means you are finding the y in terms of x. That means solving a differential equation. So you got a differential equation, this one. You got a point for the final particular solution. And what you are doing is find the function of this curve. That means finding a solution of differential equation. Okay, right. So I'm given dy by dx is equal to 2 over x squared, 3y over x. Now, it's not in a standard form, so I will rearrange it to obtain it in a standard form. So what I will do, my dy by dx plus 3 over xy is equal to 2 over x squared. So this is my P and this is my Q. Okay. My PX is 3 over x and QX is 2 over x squared. And then it's a standard approach. Until you figure out all the C and the Y is equal to something, that's your general solution. Then we'll plug in when x is 1, y is 1. This is the value of x. This is the value of y. And the unknown C can be obtained. But the final solution without C will be called the particular solution. And that's your answer. Okay. Now, I'm not sure if I said that, but the difference it will make, I think I might have. I'm just repeating again in case. The general solution and a particular solution. General solution with C represents a family of curve. If C is 1, one curve. If C is equal to another curve. C is equal to 3, something else. C is equal to 10, something else. But when I replace that C is equal to a particular value, it's just one curve. And here the question is asking for that particular curve. If you keep C as a family of curves, right? Okay. Okay, so let's go for our mu x to start with. By now, you should have remembered mu x is equal to e raised to integration minus px dx. E raised to minus 3 over x dx. I don't need 3, I'll keep it outside. Integration 1 on x dx. 1 on x is ln x. We keep them negative 3 on the power, e raised to ln x power negative 3. E and ln will cancel one another, leaving you x power minus 3, or 1 on x power 3 is my mu x. Right. Once I figured that out, I will go for the second part where I will talk about the solution, the general solution. Y will be mu x c integration qx over mu x dx, where, as usual, I just separate that part. Yeah, q over mu, I'll separate it. Integration qx over mu x dx. Qx, what was the value of qx? 2 over x squared. This turned out to be easier. 2 over x squared, and mu x, which is 1 over x3. Leave the 2 over x squared times by x3 dx. Turns out to be 2x x squared. Okay, so once I figured that bit out, my next step is y is equal to mu x c plus integration qx over mu x dx. I replace that bit. Mu x was 1 over x3 or x power minus 3. C plus this was x squared. So I can say c over x3 plus 1 on x is my y. That's the general solution. Okay, now this curve passes through 1, 1. So therefore, when x is 1, y is 1 as well. When you find x and y, replace it 1 by 1. So c plus 1 is 1. Therefore, c is equal to 0. Right? Once I get c is equal to 0, I'll have to put it up here. And therefore, y will be 0 over x3 plus 1 on x. Did I get 0 or 1? What is the point? Yeah, that's fine. Therefore, y is equal to 1 on x. See, this was a family of curve. Once I replace a particular point, right, the curve passes through that point. Only one curve will pass from that from the family of curve, right? And that curve is represented by y is equal to 1 on x, rectangular hyperbola, right? Let's say if the curve was something else, right? And this bit is extra. If the point was, for example, 1, 2, I replace it here. So 2 is equal to c over 1 plus 1, which will mean c is equal to 1. If c is 1, I replace it bit here, 1 over x3 plus 1 on x, different curve. Right? So it depends on a value of the point. C will be different, and therefore you have a different curve from there. Okay. Right. Okay, let's take one more example. If you have something like dy by dx minus 3y is equal to e raised to 2x. Again, pause the recording and try to solve this question, finding correct p and q and all the steps that we did. Okay? Now, px is minus 3 and qx is e power 2x. First step is mu x. E raised to negative px dx, e raised to negative of negative 3, simply e raised to 3x is the integration part of mu x. For our y, which is mu x bracket c plus integration q over mu dx, mu x, which is e power 3x. See, if it is not so horrible, you can continue doing it the same step, right? Q, which is e raised to 2x, e raised to 3x dx. This will be an easy bit. Once you simplify, can I say e raised to negative x, like 2x minus 3x? Yeah. And therefore, my y is e raised to 3x bracket. What is integration of e raised to negative x?
Just e is to negative x, yeah.
Yes, and with a minus in the denominator.
Yeah.
Yeah. This is with respect to the formula e raised to ax dx is 1 on a, e raised to x, of course, plus c. Right. Then just simplify it. So c e raised to 3x minus 3x minus 2x, can I say e raised to 2x? Or you can take e raised to 2x common, c raised to x minus 1. Yeah, this is my final y, all this one. Both of them are good. Right, so that was an extra question that I had. Again, pause your recording and try to handle this question. Dy by dx minus this bit times y is equal to 2x squared. Dx is minus x plus 3 x squared plus 2x minus 3. You can simplify it here only. You don't have to wait for the other thing, right? And my qx, which is the right-hand side, which is 2x squared. Okay. By factorizing, product sum factor or AC method, which I call it, x plus 3 and x minus 1, simply minus 1 over x minus 1. Or you could have said 1 minus x. Okay. I prefer x minus 1, 1 minus x. Again, when you're integrating, it will be tricky. Okay. Now, once we identify P and Q, e raised to minus px dx. Okay, so the minus will be taken care of. Good. Minus and minus will be gone. 1 over x minus 1 dx, e power ln x minus 1, and that is simply x minus 1. So my mu x is x minus 1. Okay. Now, the other bit, the y part. Y is equal to mu x c plus integration of q over mu dx, next, which is x minus 1, c plus q. Q is 2x squared over x minus 1 dx. Now, this thing here is kind of tricky. Would you provide any input here?
No, I don't know
Right.
what I would do.
Yes, so it is called improper fraction, improper polynomial fraction, where your numerator degree or the power is higher than denominator. So you can't integrate that as it is. So you have to go for polynomial division, right? And then simplified. If you could all of a sudden think of something that, hey, I got x minus 1. If I subtract 2 and add 2 in the numerator, then it can be splitted. That's done as well. If you're not that confident, not that sure, then you have to go for polynomial division, which I'm doing here, right? So 2x squared x minus 1. We used to do this in math 11246 and math 11247, polynomial division, right? The first step is 2x squared over x. That is 2x. I'll start with 2x. 2x times x is 2x squared. 2x times minus 1 is negative 2. It's minus and plus. This is gone. So simply leaving as 2x. Right? I will have plus 2. And that will be 2x minus 2. Minus and minus will be plus 2. So the whole 2x squared will be written as 2 2x plus 2 times x minus 1 plus 2. Once you expand it, you will be able to verify this. Okay. We replace this arrangement of 2x squared in here. So my y will be x minus. See the reason why I was always insisting on separating that part out? You don't have to carry that long bit always. 2x squared, which is 2x plus 2. Okay. We split out. So integration of 2x plus 2 plus 2 over x minus 1 dx. Yeah, splitting the numerator. Okay. And then is a comparatively easy integration. Okay. So y will be x minus 1 c plus, Integration of 2x is x squared. 2 is x plus ln x minus 1. That's it. And I'm not sure if you can even simplify it further. So just leave it like that. X squared 2 and yeah, just write a bit nicely. Doesn't make a difference, but I'm just writing it, hoping that I could improvise my writing. That's it. It's the same step, don't worry. You just wrote it a bit differently. Yeah, that's it. Cool. So having done some practice of this integrating factor solution method, we go to our next step of Bernoulli equation. Okay. Now, what we have done so far are special cases of Bernoulli. Okay, so first of all, I'll talk about Bernoulli and what it is. Whatever we have seen so far, you had only qx on the right-hand side, no y term. Here we are introducing some y term. So an equation of the form dy by dx plus px times y is equal to qx y power n, okay, is called as Bernoulli's equation. What we do, how do we solve it? We divide by y power n, becomes y power negative n, dy by dx, px, there was one power, becomes 1 minus n, and qx. Now we introduce new variable z. Z is equal to y1 minus n, y power 1 minus n. As differentiation, dz by dx, power comes in front, reduced by 1 power, so becomes negative y power negative n divided by dx. I have this term here. So if I make this as a subject, this thing will go in denominator. So 1 over 1 minus n dz by dx, which I'm going to replace it, this equation. So 1 over n dz by dx, px times z is equal to qx. If I multiply this by 1 minus n, dz by dx is equal to 1 minus x, px z, and this is our linear differential equation, right? It is similar to dy by dx. This is your whole p. We call it small p. And this is your new q. We call it small q. And then once we integrate everything, finally, we will replace our borrowed variable z, because the question was in xy. The answer has to be in xy. Okay. How is it connected? We are saying n is not 0, 1. What happens if n is 0? It will be standard, what we are seeing, linear ODE. If n is 1, okay, I'll write it here. If your n is 0, is inhomogeneous, which we have seen. If n is 1, that becomes the homogeneous differential equation, which we are just seeing. Okay? And greater than 1 is this part here. Right. Let's look at an example. dy by dx plus y by x is y3x, y3 ln x. Right. So we will realize it's a Bernoulli's equation because it's not just qx on the right-hand side, qx along with something. Okay, that's Bernoulli. So the first thing, we go for capital Px, which is 1 on x, capital Qx, which is ln x, and n is equal to 3. We have our z is equal to y power 1 minus n. So y power 1 minus 3 or y power negative 2. dz by dx plus 1 minus n. Z is equal to 1 minus n qx. Following it from the theory here. Yeah, this bit. And then we will call it as small p and small q. I call this bit as small p of x, and this bit as small qx. Okay. So small p of x. If you want, you can call it R and S, like anything else. Okay? I'm just following the booklet that we have. And capital QX, sorry, small qx, 1 minus x. Okay, right. So what is my small qx? 1 minus n, so 1 minus 3, it is minus 2 px, which is 1 on x. So minus 2 over x is my small px. Okay. Now, what do we need? We follow the same theory. If you want, we can go for small qx, that is minus 2, this qx, which is ln x, minus 2 ln x. So we got small p, we got small q. Now we follow the same approach we did prior to introducing Bernoulli. Okay, right. What was that? Remember the mu x and then y is equal to mu bracket c plus integration of q over mu dx, same thing. But the p and q will be small p and q, the new functions, right? Because in terms of new function, only is that method will work, yeah? Right. So mu x will be e raised to minus, remember, this is small p. Okay. What is my small p? Minus 2 on x. Can I say 2 ln x? Then x squared, or simply x squared. So my mu of x is x squared. Okay. Now my variable is z, is not y anymore. Okay. So my z is mu x, what was it, c plus integration of, remember, small q. This is x squared, qx, small qx, which was minus 2 ln x over x squared dx. Again, that integration you can always split out if you need, right? If you think that don't know how to do it and all that, you can always split out. Okay. Where I'm going to split out integration of minus 2 ln x over x squared. How do we integrate that? How do we integrate that? I think I'll need more space. I'll go to the next slide, but think about it. Yes, Kira.
Yeah, I don't know how I would integrate that.
Oh, good. Do you remember integration by parts, integration UV rule?
I remember doing it. I don't remember how to do it.
Okay. Okay, that's fine. But at least you have dealt something like that, right? Integration
Yeah.
UV. Yep. And do you remember LIATE, Liat order?
Yes, I
Yes.
do. Yes.
Yep. That's what we will need here, right?
Yeah.
So what we will do, integration UV dx. See, various book has different approach. I will follow this always. Integration du by dx, integration v dx, dx whole. Okay, we will follow LIATE. What is it? Which one of this will be u and other will be v? Okay, L4 logarithmic function. That's your priority number one. So whenever you see anything log, that's your u all the time. Everything else will be v. If there is no logarithm and there is that inverse trig function, that's your u. And then there is this algebraic. Then there is this trig and exponential as your last priority. In this order, you will choose your u and the other part is v. Okay. Since we have got an ln here, that will be my u. So u is ln x. Okay. So again, refresh this from your previous year, last year concept as a reference. Unfortunately, because of time constraint, I won't be able to take you back to the whole content you learn in a term. Please revisit. If you struggle, get in touch and I'll help where I can. Okay? Right. So integration of minus 2 ln x over x squared dx. Since based on a Lie order, I have figured out that u is my ln and v is 1 on x squared. Don't worry about that negative. It can wait outside. Okay. So negative 2. The formula says integration of u v dx is u integration v dx minus du by dx integration v dx and whole dx. Okay. U, which is ln x, integration of 1 on x squared dx, right? Minus integration du by dx. What is differentiation of log? Is 1 on x, integration 1 on x squared dx and dx here. Integration of 1 on x squared will be negative 1 on x. This is 1 on x times by negative 1 on x dx minus 1 on x ln x minus minus plus integration of 1 on x squared will be again minus 1 on x. All right, I give the minus inside, so 2 over x ln x plus 2 over x. That is that middle part of it. Okay. Now I have to talk about y. Oh, sorry, z. I meant z. This is just a part of it. Okay. And therefore, I'll just do it here. My z, which was x squared, c plus that integration part, which we have figured out just now. So my z or z, whatever we call it, c plus 2 over an ln x plus 1 on x. I'll multiply with x squared. So cx squared, 2x ln x plus x. This is my z. Remember, z is a borrowed variable. You have to put it back. Okay. So z, I'll go back to the blue. The green was only for that integration part. Z, which was y power negative 2, therefore y power negative 2 is whatever we got. What do we get? Cx squared plus 2x ln x plus x. And therefore, y squared is 1 over. And therefore, y is equal to plus or minus. Don't forget plus or minus. 1 over cx squared 2n ln x plus x. That's it. It's a few extra steps, but that is your final one. So, okay, we got one more question to practice. Xy dash minus 2/3 x squared y is equal to 2x squared y 4. Right. There is this x terms. Please take care of that before you do anything else. Okay. So first step is getting rid of that term. So my y dash minus 2/3 xy is equal to 2x3 y4. So now it is linear. If you can't get rid of it, then it's non-linear, and there is a different approach of doing, like a lot of numerical techniques are there, but definitely not what we have learned so far. So that's the first thing you should take care of. Okay. Now, once is that form, we will figure out about P and Q. So my capital PX is minus 2/3 x, and capital QX is 2x3. Oops, my bad. My bad. That was x squared only. I confused it with 4 power. So simply 2x, right? And my z or z, 1 minus n being 4, 1 minus 4, y power minus 3. Okay, now I'll go with small px, which was 1 minus n and capital Px. So that's like minus 3 px, which is minus 2/3 x. Nice and simple. Small px is 2x. Then I'll go with small qx also. Again, 1 minus n, capital Qx. So that's like minus 3 times Qx is 2x. That will be simplified as negative 6x. So they're not that horrible, right? Which is a good sign. Now, we solve the whole equation in terms of z, like the previous approach we did in homogeneous equation, the mu and c and q over mu stuff. And then we will replace back our z. Okay, so mu x, which was integration e raised to, remember this is small p, e raised to minus 2x dx, e raised to minus x squared. And it can't be simplified, that is my mu. Okay, my z or z with mu x c plus integration of q, very small q, over mu x dx. I will replace this as e raised to minus x squared c plus okay. Small q, what was our small q? Was negative 6x e raised to minus x squared dx. It turned out it's horrible. Okay. I just simplify a bit. C plus integration of, I'll keep minus 6 outside for now. E raised to x squared x dx. Now, when I see two functions, again, the first thing I would think of is, can I assume one of them is t and other dt? No? Can I convert that? If that's possible, easy stuff. This is what your linear integration you would do it, right? Okay, so I will again split that bit out and do that part. Okay, so where integration of e raised to x squared and x dx, if I let my x squared as t, then 2x dx is dt, and therefore x dx is half dt, which I replace it here. This will become e raised to t half dt. Don't worry about half. E raised to t is e raised to t. Put it back. This will be half x squared. Right, so I got that part sorted. Now I'll go back to the question. So my z was e raised to negative x squared, c minus 6 e raised to x squared and x, which I just integrated. C 6 times half e raised to x squared multiplied inside. So that will be c e raised to minus x squared. That will become 3, just 3, because e raised to negative x squared and plus x squared will be gone. Yeah, okay. Now, this is still in z. Remember, z was y power minus 3. Yeah, so z was y power minus 3. Z is equal to 2y power minus 3. So 1 over y3. Okay. Okay. What is our z? C e raised to minus x squared. C e raised to minus x squared minus 3. Once I flip it, 1 over c e raised to minus x squared minus 3. Yeah, there is a minus here. And therefore y 1 over c e raised to minus x squared minus 3 power 1/3, and that is my final answer. Bing, 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 bing. Yeah, that is my final answer. Okay. We are almost getting there. Just a few more questions and then we are done. Okay. All good, Kira?
Yeah, all good. Yeah.
Cool. Okay. Right. So structure of general solution. This is kind of FYI. I mean, if it confuses you, don't worry about it. We have been doing those questions. So kind of pretty obvious thing. So when you got a differential equation of this form, we call it YG, the general solution, YH and YP. YH is our solution from the homogeneous part. C e raised to integration minus b dx, and the YP part is obtained with the other thing, and then you add it. You have seen this part. We have been taking care of this part. Yeah. Yeah, it just been written differently. I prefer writing the mu part that we are doing. Just follow one particular bit all the time. So that's why you will never get confused. Okay. There is this example. Solution is in a book step by step. So I'm not doing it here. I'll quickly tell you page 27, where this is being solved, right? It is being solved for us. Step by step solution is given. That is really lengthy enough and kind of, yeah. So I'm not doing it. But if anyone struggled to find why this is a solution and what step, please get in touch. I'll explain it step by step. The only thing you might struggle is there is that square block explanation, which is using integration UV rule, the Lie order, but use it twice. Yeah, I'm not sure if that was been taught or proved last year, but if not, I'm happy to cover it if someone has doubt over that. Okay. So how do you find the general solution of R? This was already covered, I think, in session 1 or last week's session. Given E is equal to E0 sine omega t, then find the specific solution under the initial condition when 0 gives you 0. Yeah, and the same thing like 0, 0 coordinate or y of 0 is 0. Here is I of 0 is 0. We are given this equation, but E is equal to E0 sine omega t, right? Solution will take a approach where you will call this as A, this as B, right? And then solve it using the linear differential equation that we have seen and integrating it. And this is the solution. Looks very horrible, but trust me, once you do it, it's not that bad, right? You just have to do it step by step. Again, solution is there. If you want, I can post that page picture, in the Moodle site. Okay. And yes, this is the graph of what you get. Depends on some YH, YP, and Y, the solution that we have seen, right? So if you set that as 1 or 100, 0.5 or 50, like I explained, plus C will represent a family of curve. Once you have a particular value of that C, it will be representing one particular curve. And that's it. Thank you very much, guys. Any doubt, please get in touch. Happy to explain it one-to-one. But like I said, don't make this a practice. Try to attend the session. If not, seek my help. Yeah, I'll stop the recording. Thank you. See you next week.